All right, so yes, like you said, my name is Ben Ilegbodu. I'm super excited to be kicking off Reactathon this week. Today starting with the Fundamentals Conference, and then tomorrow and Thursday, the Advanced Conference. So what I want to do, like Brian said, is I want to kind of introduce you to React, kind of warm you up to all the different talks that you're going to hear throughout the rest of the day today, the different concepts about React, JSX, React Native, et cetera, et cetera. So I called this talk Why React, but another title of the talk could have been 10 Reasons Why I Loved React. Just wait until you hear number 6, all right? Because I really do love React, and I am going to mention 10 reasons why. But it was 2 years ago at Eventbrite where we embarked on the journey of transitioning our front end from Backbone over to React. And I'm certain that many of you are in the process of doing that, have gone through that, because Backbone was all the rage a couple of years ago. So I'm not going to speak too much about that specific transition, but if you have questions about that, you can certainly come and find me, and I can tell you all of the, I don't want to call it horror stories, but I'll tell you all the stories. I'll tell you all the stories about them, okay? But a small group of us had to convince like the rest of the company that transition was worthwhile, that investment that we were going to make made sense. So what I want to do is kind of pull back the covers of the rationale, the reasons why we thought moving to React made sense. And so in doing so, I'm going to introduce how React works, but I'm not planning to actually teach you React if you don't know it already. I actually did a full day workshop yesterday on React. I see some folks here that were in that. But you will see a lot of React and what React does as we go through the slides. So I did tweet out a link to the slides on my Twitter account, BenMVP. So if you're the type of person who likes to jot down furious notes like I do, you don't have to. The slides will be available. I have tons of links and stuff throughout the slides, so that's available to you there. So it's early, we're just getting started. Maybe some of you haven't had your coffee yet. So what I want to do is I want to get everyone to stand up with me. I get everyone to stand up. So what we're going to do is that we're going to do 10 squats like this, just to warm ourselves up, okay? I want to make sure everybody can see. Okay, so 10 squats. We'll do it all in unison. I'll count it down together. So, if you're not physically able to do it, please don't feel self-conscious. This is just something to get the juices flowing so that no one yawns and sleeps during my talk, okay? So we're going to count down from 10 down to 1, okay? So let's do it together. Ready? 10, yeah, 9, 8, there we go, 7, never thought you were going to do this, huh? 6, here we go, 5, halfway there, 4, 3, really try to go all the way down, 2, and 1. Awesome, great job, everyone. Great job, great job. Very good. Okay, so now the blood is flowing, it's pumping. Your brain is activated to hear what we're going to talk about. Okay, so just to formally introduce myself, like I said, my name is Ben Ilegbodu. I'm a Christian, a husband, and a father. This is a picture of my family, my wife Rashida. We've been married 7.5 years now. My older daughter in the back, who's holding my hand, Simone, she turned 4 last week. And then my younger daughter in the front, Avery, she's a year and a half. And we live in Pittsburgh, California, where I call it the Far East Bay. So it's not even the East Bay, it's like Far East Bay. And we had lots of BART issues today trying to get in, but that's okay. I am a principal front-end engineer at Eventbrite, like was mentioned. And if you haven't heard of Eventbrite, Eventbrite is an online ticketing and events platform where people host events. You can buy tickets to different events like conferences. So probably you've heard of us, but apparently this conference hadn't heard of us because they used our competitor. There's only a little hard feelings, only a little. But I'm on our front-end platform team. We don't deliver the actual end features that you would see on eventbrite.com. We kind of support all of the other front-end teams and front-end engineers that build upon the platform that we work on. So our two main objectives is that we build our front-end infrastructure, so like Webpack, Babel configurations, all those fun things. And then we have a React component library, our Eventbrite design system that we help maintain. So lastly, even though I've lived in the Bay Area for 15 years, I'm from Houston originally, so I'm a diehard Rockets fan. James Harden's my favorite player right now. And every year I come up on stage and I say, okay, this is the year the Rockets are going to do it, right? And every time the Warriors win or the Cavs win. But this is going to be the year. We're #1 right now. I'm feeling it, okay? So you heard it here first at Reactathon. Ben said the Rockets are going to win the NBA championship. Okay. So anyway, let's move on from that. What I want to get into, I've kind of split into two main sections. So the first section is what I call the core stuff. And that's the parts that are in the core React library, and something that should apply to everyone here because it's in the core React library. So first thing I want to talk about is JSX and how it's declarative. So here we have some JSX on the screen here. We've got a div. It's wrapping a span tag that's displaying some content, and there's a button that you can click on. So it looks very much like HTML. It should be pretty approachable if you've done HTML before. It turns out actually that React existed before JSX existed. We kind of assume they go together. They're always together, but you didn't always build React applications with JSX. And many people actually didn't like JSX syntax at first because it felt like we were putting HTML in JavaScript, and you're supposed to have separation of concerns and whatnot. But what you may not realize is that this syntax, this XML, HTML-like syntax that you put inside your JavaScript files actually gets turned into JavaScript. So with the power of transpilation tools like Babel, that JSX that I showed you before actually comes out like this so that the browser can interpret it. So we have a react.createElement. That's going to create a div. So that's the first parameter. And then we don't have any attributes for the div, so it's a null. And then all the remaining parameters are the content of that div. Oh, and by the way, the content of that is another React create element, which was that span tag that was created. And that had a class name, and it had a content that was value. And then there's the button as well with an on-click handler, and then the plus. So I couldn't imagine having to declare my UI like this. If you're familiar with React, like this would be a nightmare having to compose this like nested tree of React create elements. But before JSX, this is how React was done, and it's probably why it hadn't taken off. I think JSX was really what helped propel it, in my opinion. So here's what the JSX looks like in the context of like a full component. And we'll talk a little bit about components and what those are a little bit later. But basically, we're returning JSX inside of the component in that render method there at the bottom. And we're returning it as if it's just an object, like we would return a JSON object or an array or anything like that. So our markup is like right there in the JavaScript. It's not separated out, which is kind of nice. So we can just use it in JavaScript like normal. But even though JSX looks like HTML, it's not quite HTML. Normally, anything you've done in HTML, you can just translate that learning into JSX. But here's an example of a label component that I'm creating. It's just, we have something similar to this in our component library. And it's wrapping a label tag, an HTML element, and I'm adding a class and a for attribute to it. But it's not class equals is hidden, it's class name equals is hidden. And it's not for to associate the label to an input tag, it's HTML for. And that's because React chose to mirror their props, the attributes on elements, to be camel cased, just like the HTML DOM is camel cased. So here at the bottom, I have an example. Like if you were to find an element, if you wanted to update its class, or if you wanted to update its for attribute, or you wanted to read it, it would be .classname, or it would be .html4. And The reason for that is legacy reasons. Class and for were protected properties on objects, so they had to come up with new names. So that's kind of the history of that. If you're curious and had done React before, it's also why if you add a click handler, it's on click, or it's on change, on mouse over, those sort of things. But if you forget and you create an element and you set class or you set for, React is really good at giving you warnings and explaining, oh, hey, you made a mistake. Maybe you meant class name. Maybe you meant HTML4. So that is really handy. So that's the brief overview of JSX. There's so much more that I'd love to cover about JSX, but luckily we have Jay here to go over JSX in more detail in his talk, Why I Love JSX. And he's pretty pumped about it. Like, it's got an exclamation point at the end of it, so it's super excited. He's coming right after me, right? So if you're thinking, oh, when Ben's done, I'm going to take a quick bathroom break and then come and watch his talk. No, you can't. You can't leave, all right? So you got to stay here. You got to hold it. I'm sorry. Okay, so that was JSX. Let's talk about components here. So React is also component-driven, and we have things nested inside of each other. So the sole way that you build your UI in React is with custom components. So components that you create yourself. Everything is a component. Your app is a component. Everything is a component. And you build bigger components by composing smaller components with markup together. So one way that we can create components is by creating a class and extending React.component, which will be a base class that gives us a lot of functionality for our components. So here I have a form field component, and it's made up of a label component and a text input component that presumably already exist. That label component is what I showed you earlier. And props are how your component is configured. So a parent component can tell your component, how it can be configured through props. So this form field has a number of props. It has an ID prop, and that ID prop is going to be passed to the label and to the text input in order to associate those two. It has a label prop, which ends up becoming the content of the label component, and it configures it that way. It has a value prop, and the value gets passed to the text input, so you know what the value of the text input is. And then it has an on-change prop, so you can know when the text input changes. So that's what the form field kind of exposes in its API. So then we have this form field component, and we can now import that form field component and another component, call this the name form component, and use it just like we would include an HTML tag. So here we have that form field component that we just defined, and we're passing in ID equals fname for first name, or label equals first. The value is actually a prop that this component is now receiving from a parent component, a fields prop, and then an on-change handler as well. So although we're kind of in JSX, like the HTML syntax should feel familiar, and you can kind of combine, this name form component is combining multiple form field components in order to create a form. So you can have like separation of concerns that way. And then you just keep doing that and keep composing until you have your full-fledged app at the top. So this app component contains the name form component, as I'm showing here. So we're passing in the fields. We're passing in an on-field change handler to do something. And probably you would have other things in there as well. You would have your header. You would have your footer. You would have your left nav, those sort of things inside of it. But basically, just components on components on components. You just got to think component-driven instead of just having one big HTML template and you're selecting stuff like you would with jQuery. OK, so the third reason about React, and this picture has nothing to do with this topic. It's just funny, in my opinion. So React is all JavaScript and uses JavaScript heavily. So in traditional UI frameworks like Backbone, I call them markup-centric in that you create your HTML template and then you write some JavaScript that's going to do something to that template, select elements and add event handlers and things like that. So here is a simple template where there's a section tag, and there's this variable called heading text, and we want to conditionally render that heading text if it exists in the H1. And if it doesn't exist, don't render it, and then we'll put the contents there in the p tag. So the consequence of this, in my opinion, is that now this template framework has to have its own language for doing logic and loops and calling methods and all those sort of things. So it has to basically come up with a whole language itself that you have to learn in order to be able to do all the things that you would want to do in the template. And if it's limited, like handlebars is, then it becomes a pain. And that was really a big pain with Backbone, was the limit of handlebars. So if you had a conditional, you couldn't do if this or this in handlebars template. Like, it just wasn't possible. Even doing if and this was a pain, and doing if else you couldn't do. So it was kind of pretty challenging. So if you move to React and you're used to that HTML template approach, you may try to do something like this in React. Try to find a way to do conditional rendering, put a conditional in JSX. But we can see that this kind of doesn't look right. We have curly braces in weird places, and this would just become a syntax error, actually, because we're trying to conditionally render heading text in the JSX. But what happens is that JSX doesn't have any special syntax, any special language for conditionals or for loops. You use JavaScript to do that. So there's no API. So here's one way that you can do conditional rendering in JSX. So essentially what you would do is you would create a variable. Here you have heading element as a variable. Initially it's unassigned, so it's undefined. And then if heading text exists, then you assign the heading, the H1 with the content to the heading element. And then you render that inside of the section. And that's how you can do conditional rendering. So if the heading text doesn't exist, then heading element will be undefined and nothing gets rendered. React is able to handle that. So in this case, I call React logic-centric, in that you have your logic, you do most of your logic, and then, oh, by the way, you're going to render out some JSX at the end. So it's very JavaScript focused. So, but if you strip away kind of the JSX, this is actually what it gets transpiled to. So, and this looks like just all JavaScript, right? So we have that same heading element. We have the conditional around heading text, and then we assign react.createElement to heading element. And then we return back a new object, with heading element being the content there on the second to last line. So it really is all JavaScript in the end. It's just we have JSX as syntax sugar to make it a little easier to build our user interfaces. So I will say, though, that the way that I've shown you how to do conditional rendering is probably not how you're going to see it in React code or how it's done at your company. Typically, folks will do expressions inside of the JSX to do conditional rendering. So here we have heading text and this H1. So if heading text doesn't exist, it will just render undefined again. But if it does, then it will render the H1. And it's a kind of inline way to do it with a little bit less code. But at Eventbrite, we strive to keep our JSX as clean as possible. So we try not to have so much logic inside of the JSX. In this example, it's okay, right? It's like a one-liner. It's pretty straightforward. But if your markup had props on it, attributes, if the content was multi-line, like I've seen something like this stretch 10, 20 lines, and it's kind of hard with indentation to figure out where things started and where things began. So we go with the previous route. So Dan Abramov, one of the React maintainers, tweeted this last year in a response to add conditionals and looping constructs to JSX. So I love JSX, or love JavaScript, so the more I can do in JavaScript, the better. So I'm glad I don't have to learn a new API in order to do loops and conditionals in React. But because because it's all JavaScript, then I can do whatever JavaScript can do, which is pretty nice. But for some, though, it's a drawback because basically you have to know JavaScript pretty well in order to do React. Like in the past, if you were really good at just like HTML and CSS, you could make your template, make it all beautiful and stuff, pixel perfect, and then you could like sprinkle in some jQuery, and it would work, and it would do whatever you needed to do. It would probably turn into jQuery spaghetti code, but at least it would do what you needed it to do. And to be honest, looping and conditionals in React at first is just not intuitive, right? You're just not used to having to do it that way. But once I think you learn how it works, then it's fine. So there's this Stack Overflow link at the bottom, which is a question on how do I do looping in JSX. And it's got 430,000 views, and it's got 625 upvotes on like how to do it. So it's clear that it's a problem, but I still think React made the right decision. But now it's JavaScript or bust. Okay, so far we've talked about JSX, right? We've talked about how React is component-driven. We've talked about how it relies on JavaScript. But so far we've kind of been creating static user interfaces, right? There hasn't been any user interaction. And to do that, the state of your UI has to change over time. Like that's how you have an interactive user interface. So React components are state-driven instead of event-driven like we're used to. And I would say that this is like the hardest thing to get your mind around when you're talking about React, the fact that it's state-driven. But I would say that once you've got it, you can build amazing things in React. So let's take a look. So we've got this UI here. It's written in jQuery. All it does is basically you click this button and it increments, just like that. It's highly sophisticated, right? So in jQuery, here I have this template. There's a div or a span with a class that has the value, and then a button with the plus sign. And then we add some jQuery where we select on that button, add a click handler, and then get the value out of the HTML as a number, increment it, and then put it back in the HTML inside the span tag. So the driver of this is the event, is that click handler. So you get the click, and then you do this, and then you do this, and you set the value back. So this is like super easy to understand. It's like 4 or 5 lines of jQuery because it's very imperative. But as your app grows and as everything is event-driven, the complexity just goes crazy because sometimes you have to like trigger manually or programmatically trigger events to get your UI in a certain state because you have to do this and this and this to get there. It just gets kind of crazy for anybody who's tried to build something of complexity with jQuery. So alternatively, with React, it's state-driven. So this here is the equivalent of what I just showed, but in React. It's like the simplest example of reactivity in React. So first, what we have here is we have the state. And it's initialized to 0, just like before the HTML had 0 inside of it. So then that state is rendered out into the returned and render in the span tag. So it's put there, 0. So then the person's going to click the button, right? Going to click the button, and then we're going to handle the click with this function method, handle click. So then handle click has the logic of taking the previous state and incrementing it, and then calling set state. So I'm using ES6 syntax here to try to make it as short as possible because I had to actually fit it on my slides. But in the end, we're calling set state with the new value. And as a result of calling set state, render gets called again in React. And then now the UI gets rendered with the value 1 inside of the span tag. And that's basically how the interactivity is built. And you would click the button again, and the same thing would happen, and then it gets added there. So In the old world, right, in handle click, we would increment the value and then want to immediately update the DOM, right? Like we were doing in jQuery. And when you handle the event, you just want to update the DOM yourself and make the update. But here in React, you actually update the state, and then the state will then cause a render, and then that updates the DOM. So it's like an additional level of indirection, and it's that level of indirection that's like the hardest thing to grasp, that the way that I update my UI is actually by updating my state. So when you really boil it down, like React development, I boil it down to like two main things, two main areas. So you define what you're going to render based upon the props that your parent passed to you and the state that you're maintaining yourself, right? So the way that you render it, you can have conditional logic, you can have loops, you can have utility functions, like all the sophisticated logic you need to render out that JSX, that UI. And in this area, like the skill that you need is the ability to be able to create layouts, right? So HTML, CSS to create something that looks nice. So then when events happen, and that event can be an on-click, it can be a mouse over, it can be time passed, whatever the event that happens, when events happen, then you need to do something to transform your data from the old version of the data to the new version of the data. And that transformation can be asynchronous. You can make an API call to get back new data. You can do validation of information. You can do all kinds of things there, but you transform from old to new. And the skill there is that ability to do that data transformation efficiently. And that's where algorithms really come in play so that you're not spending too much time doing that. And then once you make that data transformation, you call set state, and then the UI updates and render happens, and then the render is now rendered based upon the props and the new state. And then the cycle continues and the loop goes on and on and on. And that's basically how you build interactive apps in React. And you profit. So Dan, again, had a tweet. Because when folks look at simple examples of reactivity, what I just showed you in React, they find it to be too verbose. Like, that's way too much code to be able to do something that I could do in 4 lines of jQuery, right? And it is too verbose, or more verbose, I would say. But what React does is it trades conciseness of your code with predictability. Like, everything that gets done, you wrote, and you can see it happening. The only real magic is that set state, or that render gets called as a result of set state. Like, that's where the magic happens. But everything else is just like you writing your code. So you're gonna write more code wiring things up and passing props down. But the nice thing is that the structure of your code is gonna stay relatively the same as you build bigger and bigger things. Like a complex app, the difference between a complex app and a simple app is just the complexity of whatever the feature was doing, not that you had to restructure your code and things like that. So that's certainly not the case with some other frameworks. But if you're getting into React, if you're not familiar, I would say be aware that when you're starting off, it's going to feel like you're writing more code. So Feather here is going to give us a talk. That was a quick overview of how React works and reactivity works. It's really the crux of React. And like I said, it's the biggest mental shift when developing in React, but Feather's going to go more into kind of declarative approaches with React, kind of taking how we used to write code to how we should write code with React. And she's coming up right after Jay, right? So if you were like holding it in because Jay was talking, you still can't go to the bathroom. You still have to listen to Feather's talk. And so sorry, you're going to be holding it for a while. Okay, note to self, jokes about pee don't go well. Okay, so let's quickly jump into this 5th aspect of React. And this is where the magic really happens. This is the magic of React. It's the reconciler. It's what's called the virtual DOM. It's the cool feature everybody talks about with React. Technically, the virtual DOM is a misnomer. and I'll explain a little later why that's the case. But up until this point, it's kind of looked like, or I made it seem that render is updating the DOM, right? But technically, it's not. So let's look at our example from before. So when we call set state, React calls render on our behalf, right? And it looks like it's re-rendering the entire div with the span, with the button, all over again. And we know that that would be super inefficient, especially on a bigger app, to re-render all this UI again, when really the only thing that's changing is the content of that span. Like, that's really all that's happening. That's really all that's changing. We don't want to add new on-click handlers on the button, for instance, and things like that. But that's actually not what's happening. So render is not updating the DOM, but instead, all it's doing is building up an element hierarchy. It's just like describing what the UI should be like. So basically, React, it maintains, when it renders your initial UI, it maintains a copy of what the DOM looks like. And it has a copy. Then you recall render, and it now looks at a new copy before and after of the DOM. And it says, oh, what's different between after and before? Oh, the difference is that there's a number 1 there instead of a number 0 there. Okay, now I know that the only change I need to make is to update the inner HTML of that span tag instead of re-rendering the whole thing. So it basically, React does the work that we know that we would have to do ourselves. So those kind of micro updates, like, oh, I need to update the inner HTML here, I need to update the class of this here. React does that on our behalf. We just describe what the UI looks like based upon the props, based upon the state, and then when the state changes, it makes the necessary changes. And that's what the React reconciler does on our behalf. And that's just a killer feature. Like, it makes React development, makes UI development, in my opinion, like so much easier than previous ways of doing it. So, well, that's supposed to be a video of something, a screenshot of a YouTube video. Lynn Clark at ReactConf last year gave an intro to the new fiber reconciler that came out, which opens the door to even more sophistication for React development. So this video, if you get my slides, will show that. And Lynn did an amazing job of explaining kind of like the technical aspects of how it works and how it's able to do what it does efficiently on our behalf. So if you're kind of interested in that magic of React, I suggest you check that talk out. Okay. So that was the core stuff, the ones that will apply to everyone because it's part of the core library. Now I want to move on to the more stuff. You see what I did there? Core stuff, more stuff. Yeah, thank you. I spent way too much time trying to figure that out, so I'm glad I got one clap. Thank you. So these are extra things that may or may not apply to you, but there's stuff to know about. So let's talk about server-side rendering. Isomorphic React is kind of what it's called, and it's the idea that your React components that you are rendering on the client, you can also render on the server, so you don't have to duplicate that. And that's for like initial server rendering, just initial server render. So the 3 main reasons, in case you're wondering why you might want to render on the server, is performance. So the initial page render is just faster if you render server-side than if you have to render an HTML shell, download the script tags, and then finally render on the client. So it's just faster. For SEO, Google doesn't have to execute your JavaScript to get content, meaningful content, if it's already there. And they also use page rendering speed as a factor into their algorithms, into their weights. And then lastly, Open Graph is an interesting one. So whenever you share a link, like on Twitter or on Facebook, in Slack, for instance, you see like a thumbnail there, preview, you see a title, you see a description, like that kind of rich content. Those are meta tags that are in the server rendered content. So you would want that there as well if Open Graph is important to you. But again, I just want to emphasize that this is the initial render. So after the page is rendered, you can do client-side routing and all those sorts of things. So let's return to this, our old friend, this incrementer component that we've been looking at. So up until this point, I've kind of made it seem actually that render after the reconciler did its thing was rendering to the DOM. But even that's not true. So render just informs what elements and child components should be rendered. It doesn't dictate how they should be rendered. Okay? So what does that is rendering typically of the DOM happens at the entry point of your app, your index.js. So first you import this library. It's called React DOM. And then if you're doing server-side rendering, you hydrate your app with data from the server, and that inserts your app into this DOM location. Here it's an element with an ID called root. So then whenever your app updates and reconciliation happens, then that gets flushed out to the DOM by React DOM. So it takes that difference. So I bring up that distinction of what render does and what React DOM does because it allows us to use the same exact UI server-side for rendering to a string as opposed to updating the DOM. So you can take this string that gets generated by React DOM server, render the string, and put that in the HTML response. And this is a huge feature that this is like natively supported in React. So you take in whatever like DB calls you want to make, post params, get params, environment params. You put those all together, pass those as props to your app, and then out you get back is the actual markup rendered to string. So with other libraries, like they were really tied to the DOM and assumed that they were executing the DOM. So rendering server-side was like a pain at best, or basically impossible. But now React kind of allows us to do isomorphic React, or isomorphic JavaScript. So if you're going to be here for the advanced conference on day 3, Tenmai is going to give a lightning talk on this very subject. So if you're going to be there, I highly suggest you talk about that or come listen to the talk because it can be helpful in that regard. Moving on, who here likes testing? Woo! Testing! So it's, as you can see, no one does really. Got a handful of people. I'm kind of a fan of testing, and React makes UI testing actually minimally painful. It's not painless, but it's minimally painful because of that separation. So again, here's the incrementer component once again, but I've added an additional line here. So this is a line that's going to call a callback event handler that we pass to it when you actually click the button. So it's going to tell the parent, hey, a button was clicked, and here's that value. So when we're testing, we only want to test the public API of our component. Okay? So that is 2 things. It's the markup that the component renders, so that's the div, the span, the button, and then it's any callback handlers that it evokes. Those are the 2 things that we want to test. We want to avoid testing internal implementation details like the state that it's maintaining, for instance. So we can test this component using Enzyme to test its public API. So Enzyme has this kind of like jQuery-like interface for manipulating React components, all without having to render in the browser. You can just run this in Node in your build process. So rendering in this environment is basically creating an Enzyme wrapper. And we, at Eventbrite, we use Jest for this as our test framework and our assertion library, which was created by Facebook. You can also use Mocha and Chai. That's a popular combination, too, with Enzyme. And we also use this library called Jest Enzyme, which adds these helpful assertions for Enzyme that I'm going to show in a second. So here, we're asserting that when we render the incrementer components, that we want to assert that we can find that span tag that had that class val there. We want to make sure that it's present. So that's just kind of a sanity check, really. And then second, we want to make sure that that span tag has the text 0 in it, because that should be the default rendering. It starts off 0. So we're verifying that. Then if you recall, when we click the button, we call that on increment function, right? So we want to make sure that it actually does that and that it calls it with the proper data. So we need to simulate clicking the button in order for that to be called. And with Enzyme, we can simulate button clicks or user interactions all without the browser. It allows us to do it. So first, we create this just mock function that's just going to listen to when it's called and allow us to find information about how it's been called. Then second, we pass that mock function as the onIncrement function handler to it. So that is our event handler, that mock. Then third, we do the simulation. So here we're simulating clicking the button 2 times. So simulating somebody calling it 2 times. Then now we want to do some assertions. So we want to ask, how many times was this called? And this is kind of a sanity check to make sure that the function wasn't called too many times. Like we've had components that were accidentally being called twice or 3 times for each time it was invoked, and that could mean like twice as many AJAX requests on accident and things like that. So we always sanity check how many times it was called. And then next, we want to make sure that it was called with the right value. So since it was clicked twice, the value that was last called with should be 2, because that was the number of times it was clicked. And then lastly, we can assert that the UI has a number 2 inside of the display, because that's what it should be at that point. So we can do this sort of testing, reliable testing with our UI, which is pretty nice. So hopefully I haven't stolen too much of Rachel's thunder for her talk this afternoon, but she's going to go into more detail about how we can properly test our React components. So certainly check that out. OK, so let's just jump right into React Native, the 8th thing. Let's bring out this incrementer component. This is going to be the last time we see it. OK, so here it looks like we're writing React for the web. We have a div tag, the span tag, the button tag, et cetera. But if we imported from React Native and replaced that div, that span, that button with view, text, and touchable opacity from React Native, we've got the makings of a React Native app. Just like that. This is how you would start building a UI in React Native. I remember going to a workshop with one of my coworkers, Ryan, and I was just blown away like 30 minutes into it. Like, whoa, like we just built a React Native app and I can use everything I've done in React for the web with React Native. I just have to learn the paradigms of how mobile development is different than web development. So I could leverage a lot of my learnings, which is awesome. For instance, in React Native, the layout engine is different, so everything is Flexbox based. But those are things that those are little details. But for the most part, it's the same UI development, which is really nice. And the nice thing about React Native as well is that there are a lot of pre-built components. You don't have to create so many components yourself. And React is not just for mobile devices. There's all these other renderers as well. I listed 24 renderers here. The new fiber architecture, in theory, is supposed to make it even easier to make more renderers because the reconciler, there's one reconciler that figures out how to go from before to after in an efficient way. And then it's the job of the renderer to actually figure out, oh, how am I supposed to put those changes in the environment? So we've got React DOM, right, that we all use. We're pretty excited about React Sketch app that allows you to render React components in your Sketch library. So now our designers, in theory, could use the same components that we're building in our design system in Sketch so that they're using the exact same components that we would be building with. And there's also React HTML email there, so you can do emails with React components. So it's all pretty cool stuff. And those are all links, so you can all follow them as well to the GitHub repos. So Harry here is a recovering iOS developer, right? And he's going to tell us about how awesome React Native is compared to iOS development. Actually, I don't know if any of that's true. I just made that up. But I have seen how our iOS developers at Eventbrite build user interfaces with Swift, and React Native is definitely better, at least in that regard. So hopefully, he's an iOS developer, right? So he'll be able to give us a good comparison of the two. So check that out. So honestly, this number 9 about React is that it's unopinionated, right? And this could be a pro or a con depending as you look at it, but it can be a slippery slope depending on your experience with it. So there are all these debates in React about the right way to do things. So if you follow Twitter and things like that, you can kind of see what's going on. Like, do you use component classes or do you use stateless functions until you need state? Should you always use set state and not use other libraries for managing state? What about the performance of inline functions in React? What about, there's like 4 different ways you can do async and Redux. You can use sagas, you can use thunks, you can use observables. And there's render props versus HOCs. And like, there's no right way, React way to do things. And like, if you're new to React and you have no idea what I was just talking about, like, how do you decide which one to pick? Because you have to kind of make a decision as you're building your apps. So that can be a pretty big con with React because there's no standard way. But I kind of see it as a pro because we can look at the makeup of our team, the skill set that we have, and decide which library we're going to use based upon what people are already experienced with. And we can tailor our stack to our skill set. So digging a little further, there's lots of decisions you can make. There's styling decisions. Are you going to use the global CSS like Bootstrap, or are you going to do modular CSS where you import a CSS file for a component and use BIM for namespace collision management? There's CSS modules that's kind of similar to that, but handles the namespacing for you. You can just go with inline styles and say, screw it, I'm just going to put everything in on the style attribute. And CSS and JS takes it even further and says that we're going to do all of our CSS in JavaScript, but it enables more than what inline styles can do, like media queries and animations and stuff like that. So, how do you choose? Like, most likely it's going to be on what your current infrastructure is. But even within CSS and JS, there's glamorous, there's a motion, there's styled components, there's Radium, there's Aphrodite. Like, there's all these decisions, options that you can pick. So even though React is unopinionated, Joe is very opinionated. And he's going to give us some examples about CSS and React and tell us kind of what options we can go with. So there's state decisions. Like I said, you use set state, Redux, MobX as examples. And Mark is a maintainer of Redux, and he's going to give us some fundamentals about how Redux works. So that's going to be super helpful. You also have API decisions. Are you just going to use a REST endpoint and make AJAX with the new Fetch API? There's also GraphQL that exists now, and Relay and Apollo are 2 GraphQL clients for React. Falcor came out of Netflix, which is kind of similar to GraphQL, which you can use as well. And John's going to he's going to give us a gentle introduction to how GraphQL works and how we can use it. So last but not least, I have this catch-all here. These didn't deserve their own section, but I wanted to mention them. So about React, there's other considerations. So there's a deep commitment for Facebook on React because they use it on their site. So it's less likely to just kind of go away. They have a whole staff around React that's dedicated to building it and seeing it move forward. So it evolves a lot. But even though it's evolving, it's still stable. So we don't have to worry about crazy breaking changes with each major release, like some other languages. It's super popular, obviously. We have a conference here. We have conferences all over the country, all over the world. and other things about React that are super helpful, like developer tools and a huge ecosystem for extensible libraries. So it's pretty great. And those things really help React kind of do well, in my opinion. So lastly, just wanted to share some additional resources with you. Those 2 links above are videos from Kent C. Dodds on egghead.io. So a beginner's guide to React, as well as advanced React patterns. They're free, I believe, on egghead.io. I know the first one is about 75 minutes, so there's a lot of content there to really kind of learn React if you're trying to get into it. The next 3 are from Eventbrite. So we had a lot of people learning React at the same time, learning ES6 at the same time. So we came up with a coding style guide, best practices around that, as well as testing best practices too. So check out those links on our public GitHub, and you can read up on that if you want to kind of take it and fork it and make it your own. And then lastly, Mark, who I mentioned earlier, has like close to a bazillion links about React and Redux and ES6 and all those things. So links to how you can learn more there. So finally, before I go, I wanted to just share some appreciations. Wanted to appreciate Reactathon for putting on this conference. Like Facebook, for whatever reason, is no longer able or willing to put on ReactConf. So Reactathon kind of fills that void so that we can still make sure we have a React conference here in the Bay Area. It makes sense to have one since it's all over the place. And also thank you to Ben and team for inviting me to kind of kick the conference off. I really appreciate that. I want to thank Eventbrite for sponsoring the conference as well. And we also, if my math is right, we've sent 25 engineers here to this conference over the 3 days. So that we can level up our skills and learn it from other people and have conversations with people to kind of grow ourselves. And this is all while we have this big company-wide initiative that's going on. So really, like, Eventbrite's really good at kind of learning and development and really helping us grow. So by the way, we are hiring. So I got to put that out there. So you can totally come by the booth and we'll chat with you. But I know that some of you are here with your coworkers, right? And you don't want to put yourself on blast, right? So you can just come up to one of us. We're wearing our Eventbrite T-shirts. Just give us the head nod, left eye wink, handshake. We'll know what's going on, and we can have a little chat about working at Eventbrite. And then lastly, I just wanted to thank all of you, obviously, for coming to the conference, attending it, taking the time out of your busy work schedule, school schedule, interview schedule, wherever you're at, to grow your skills. Like, we've got great talks coming up from great speakers. Like, that investment is really going to be worth it. So with that, I thank you very much and enjoy the rest of the conference.
Yep.